All right, so today's topic is two-way tables and probability. You will see that the first problem is already a little bit done because I started recording this and then I got a phone call in the middle and I had to start over. So first one, we'll get there. So basically a two-way table, they're called two-way tables because they are tables and they go two ways, sideways and up and down. So super fancy name, pretty easy topic. All right, and for the most part, I think you should be able to look at this and kind of figure out what's going on. It's basically a way to record experimental data. So in this instance, they did a survey of 240 people, and then this is a record of what their data was. Okay, so you can see that there were people asked about male or female, and do you prefer an SUV or a sports car? Okay, so there were 21 males who preferred an SUV. There were 39 males who preferred a sports car. Okay, and there were a total of 60 males, right? These two numbers added together give you that total of 60 men who were asked. Okay, and then similarly for the females, there were 135 who liked SUVs, right? Here's how many females liked sports cars. The total of these two boxes is the total females. And then similarly, going vertical, this number right here is the total of how many people said they liked SUVs. This is the total of how many like sports cars. And then this bottom corner is just the total number of people who are asked. You'll notice that that matches what they said for the survey. It's also the sum of these two numbers and the sum of these two numbers. Okay, so 240 is our total. So we're going to use this to find probability. It's experimental probability, which is usually easier than theoretical probability, so don't freak out. All right, so let's take a look at this. So these first questions, we want to find the probability that if you choose a person, that they're going to be female. Okay, now it's really important that you pay attention to what you are choosing from. Okay, so in this case, we're just choosing from all of these people, all 240 of them. That's why my denominator is 240. Okay, and of those, when I look at my table, there were a total of 180 females. So my probability is 180 out of 240, which is, according to my calculator, 75%. All right, now this next question asks me about males who prefer SUVs. So again, I'm looking at people. I'm just saying if I choose a person. So my total is still going to be 240 because I'm just choosing a person, okay? But we want to know of those, how many of them are going to be a male who prefer an SUV? Well, here's males, here's SUVs, right? So there's 21 of them. So 21 out of 240 people. Throw this into my calculator. That works out to about 8.75%. Okay, so fairly unlikely. All right, a person who prefers a sports car. So again, I'm choosing randomly out of all people. So out of 240 people, how many of those prefer a sports car? Well, sports cars, 84 people said that they liked those, right? It's the sum of how many men and how many women. So 84 out of 240, which is 35%. Okay, number 4. Find the probability that if you choose a random person, they will be a female or a person who likes a sports car. So I'm still choosing out of these 240. And now we want to know either people who are female or people who like sports cars. Okay, well, the females, we know that there's a total of 180 of those, right? So I'm starting with 180, that's the female part. But then we also want the people who prefer a sports car. Now, I don't want to add in the 84 because if we do that, then these 45 people get double counted, right? They were counted as both a female and now as a sports car person. So I don't want to count this 84. I just want to take this extra 39. So I want to add on the 39 males. I've already accounted for all the females who like sports cars in my total. So now I'm adding in the people who like sports cars who are not female. Okay, another way you could have gotten this number would be to add up these are the females plus the people who like sports cars. Okay, so 180 plus 39 is 219. So my probability is going to be 219 out of 240, which is 91.25%. Okay. All right, now these next questions, these are going to be more how you're going to see them phrased for the most part. So we want to find what's the probability that a randomly chosen person is male. Okay, so again, you've got to pay attention to what are you choosing from, and you'll see what I mean about this in just a minute. So we're doing a randomly chosen person. Okay, so again, we're still talking here about choosing from the people, right? And then we want them to be male. Well, there were 60 males. So it's 60 out of 240, which is 25%. Okay, randomly chosen person. So again, I'm choosing from all the people, so that's 240. And they prefer a sports car. So how many of them prefer a sports car? Well, 84 of them. So that's 84 out of 240, which is 35%. All right, and now here's where this one is a little bit different, because this one doesn't say a randomly chosen person. It says a randomly chosen woman. Okay, so how does that change our problem? Well, now when I'm talking about my total number, my denominator is not going to be 240 anymore, okay? Because now we're just talking about the women. And how many women were there? There were 180. So my denominator now is just 180 because I'm just picking from the women. Okay, how many of those women preferred an SUV? 135 of them. Okay, so my probability is going to be 75%. Okay, this next one, what's the probability that someone who prefers a sports car is a man? So we're talking here about the people who like sports cars. That's going to be my denominator. So my denominator here is going to be 84 people, right? How many of them are men? Well, 39. So my probability is 39 out of 84, which is about 46.4%. Okay, so you got to be careful here, because what I see a lot of times is people will try to do this problem like we did this problem, where they make the total how many men there are. But that's not what they're asking. We're talking of the people who prefer a sports car, so that's got to be my denominator. All right, and this last one, which I can sort of fit on here, probability that someone who is a man prefers a sports car. So we're talking about people who are men here. How many men are there according to my table? 60. And of those, how many prefer a sports car? 39. So my probability is going to be 39 out of 60, which is 65%. Okay, so that's how you're going to find probability from two-way tables. It's not super hard. It's very basic math. You just have to be careful as you're reading the tables that you read them correctly. Okay, and the big useful thing about these is that it really lets you break down your data. So you can collect a whole bunch of data, and then you can kind of clearly see the breakdown of it and look at that and say, okay, well, when we compare these, like what's going on here? Like at first glance, you might say, oh, well, looking at the sports cars, you might want to say, oh, well, more women prefer sports cars than men do. But when you take into consideration the totals of how many men and women were asked, then it kind of tells a different story. So the nice thing about a two-way table is it gives you a really good overview of what your data looks like. And then it lets you figure out these experimental probabilities fairly easy.